So here's my 24 volt power supply. I'm just using that for experimental purposes. It would be a battery in the normal circuit. And we have the encoder, a rotary encoder. This one looks like it was designed to be on a safe or something like that. You can see it's hooked up on the back side, and the wires go to the Gecko drive, which I have the cover off of right now. It looks like a mess, but actually it's pretty simple to wire these things. Okay, so we've got the encoder directly driving the Gecko drive, and so I'll put that cover back on. And I have the encoder powered by this 5 volt battery supply here, and going into a switch, and that feeds the power to the encoder. And then this is power going to the motor here, the red and black. These wires along here are those power the encoder and send the signal out from the encoder that drives this motor. And the way the Gecko drive works is it powers the motor voltage in whatever direction it needs to oppose the force. So when I turn this way, it provides voltage in the opposite direction. What it does is it counts the encoder's slots, or 0 to 1 voltage off and on, and it can determine which way this is turning. Okay, that feeds that signal, which is nothing more than two off and on signals, to the Gecko drive. The Gecko drive has a little bit of logic built into it, which allows it to send voltage out in the opposite direction, or in the direction it wants to turn the motor. You can see it's opposing the force that I'm applying to the end here. Okay, so here we have a pulley, which is it's got these little slots on it, and that's a timing pulley, and you can buy these online, and I'll put a link up for that. And so here's the motor being driven by the encoder through the Gecko drive. Okay, and so when I turn this encoder here, you'll notice that turns at the same speed. Let me put it on close up here so it won't look so bad. Okay, so what you're hearing is this encoder was made for a safe, and I didn't know that when I ordered it. And it has this little detent that you know, when you see a person operating a safe, they're counting the clicks. Well, this encoder has that clicking built into it. I didn't know that when I bought it, but since I have it, I decided to use it for the experiment anyway. Obviously, these wires here would be much longer in the actual version, and the power supplies will be contained within here. I have a little lithium polymer battery that's charging right now from Energizer that is built to power the small laptop computers. They're out now. And it's very tiny. It's about the same size as this encoder setup here. And you can see that as I'm turning this is turning the same way. And it looks choppy because I have this set. This is only a 100 line encoder. Well, this encoder has 500 lines. So I set this at a 10 to 1 ratio. So this would output, for every line it outputs 10 lines. That's why it looks jumpy. If I use an encoder with a higher encoder count, like this is a 100, if I used a 1,000 line encoder, then you wouldn't have this jumpiness, because the amount per increment would be smaller. Another thing is that detent that keeps it snapping in this different position is also affecting this over here. So if I kind of eliminate that by giving it a real tight grip, there's a little bit less of that jumpiness. This can all be worked out. This is no big deal as far as the jumpiness. It can easily be worked out. Anyway, you can see that as I turn this, that's happening. So all I really need to do is put some longer wires on the encoder feedback wiring, and put some longer wires on the DC power coming from the Gecko drive to the motor. And this is a 24 volt motor. It's huge. It's about an order of magnitude larger than what I need. I think it's a little overkill, so I'm pulling back so you can see the whole thing here. So it does work, and it will work just fine. Using a smaller motor would be even better. I just have to find one. They're kind of hard to find on eBay, and they're extremely expensive if you buy them from original equipment sellers. So I try to find things on surplus whenever possible. So there it is. Put a longer wire on here, power it through a DC battery, and everything would be hunky-dory as far as using it on location. And I'm pretty sure this is the same type of setup that they're using elsewhere, commercial systems. They just made it look prettier. So you're getting a one-to-one feedback here. Okay, another thing I'm working on over here is they have these new things out called, well, they're not new, they've been out a couple of years, called Arduino processors. And basically it's a microprocessor that's programmable. This is a ping. It's a acoustic sensor that gives you feedback to a circuit. You know, you have to program this thing to use the ping, and then you would have. Here's another one. The problem with the ping is it only has a range of around 5 feet. This one has a range of like 20 feet, and it's much more accurate. This is accurate down to an inch. It was around $38 for that, and the ping was about 29, but it has a much smaller range, so I probably won't wind up using this for anything. But what I want to do is use a servo or a servo motor with an encoder and have this drive it based on positioning. So the acoustic feedback would drive the circuit, which would allow it to drive the servo in relationship to how far away from whatever you're filming is from the sensor here. This is just a regular RC servo, and these are easily able to handle power requirements for those little RC servos. So that's something I'm going to work on in the future. I'm not a programmer, so it's going to be a long learning curve before I can get that going. This was a much simpler project over here, and I think I could have that going. Really, it's just a curiosity for me right now because I've already built this thing, which is the the one that's powered by the RC equipment. So I'm happy with it. It works fine for what I need it for, and that's all I got to say for right now. So see you guys later. Bye.